Doria, can you be quiet, please? Okay, guys. Are you on? Uh, you read instruction. There. Make sure you comment on the YouTube. Okay, guys. Are you on? Okay, so let me start. Thank you for joining me into today's first live streaming lecture. So this is my first experience teaching this one. So what I'm asking, uh, what? Okay, I need to switch off my YouTube first. Yep. Okay. Yeah, let me go through this one because I'm live now on YouTube. Can you believe this? Okay, guys, sorry. This is my daughter Adoria. Adoria, say hi to my friends, my students. Say hi. Hi. Hi everyone. This is Adoria. She is 6 years old. Now she is joining me at home because she has no ngaji tonight. So let's start today. Before we start, please take your attendance. This one should be assigned to week 5, 1. So week 5, number 1. Oh, sorry, this is week 6. Week 6.1. It's the replacement class for next week Chinese New Year's holiday. So tonight I want to revise back what we have learned for the mass balance. Yeah, yeah. For the mass balance of multiple unit system. So let's try. So there are 3 little steps to do so. So first of all, you need to go for the flowchart. Number 2 step is that you need to define system boundary. And step number 3 is actually to solve the balance. So these are 3 steps in solving the balance for multiple units. So you're given this problem. This problem has completed step number 1. So unit 1, unit 2, unit 3. So the first step to do is actually to define the system boundary and analyze the DOF for each boundary. So this is done. This is done. Okay, now we are working on the second things. So you see here there are 3 individual units. You have unit number 1. You have unit number 1. So you go for a system boundary number 1 here. We have, okay, let's assign the stream. So it's easy. This is F1. Let's say this is the F2. This is F3. This is F4, F5, F6, and F7. So the system boundary involving unit 1, here you have an F1 and you have F3 down there and you have F2. F2. So now we need to go for first the DOF. DOF, which is equal to how many unknown? 1, 2, 3. That's all. You have 3 unknowns. So it's a 3 minus. Independence balance, we know that here we have two spaces, so it's minus 2. There is no information whatsoever, minus 1. And you have one, sorry, you have 1 minus 1 here. Oh, what happened? Sorry, it's missing. So I'll repeat. So I'll repeat again. I don't know what happened. So we have three individual units. So when we address the DOF, we need to first define the system boundary. So here, so to make it easy, let's assign the stream number. So this is stream number one, stream number one. This is stream number two. This is stream. Okay, stream number I. This is stream number three. Stream number four. Stream number 5, stream number 6, and stream number 7. So first we need to identify, let's identify the first boundary is unit number 1 only. So unit number 1 become, you get this, what's going on? You get this unit number 1. So you have F1. You get, oh God, what's wrong? A moment, yeah. So you have unit number 1 over there. Here you have F2. Here you have F3, yeah, F3. Then we do the DOF. So the DOF for that. Oh, what is this? So you try to get the DOF for this one. D A. I don't know what happened. Wait, Adoria, wait. Can you just go? Okay, wait, guys. I need to find a better place to do this. So I will do just here. So we have this. What? Okay, let me repeat these things. So you need to do it one by one. So it's a. Oh, I don't know what's wrong with my laptop. Yeah. Let me set this thing.
Set what? Teacher Daddy.
Can you take my phone, please? Yep.
Wait, hey up, hey up. Don't come here.
Adoria, can you go, please? Can you go to your room, please?
Daddy, I
Okay, guys, sorry for this problem. So sorry, I we go first again to problem number one. Uh, so this is basically the revision of the three step to solve the mass balance in multiple units. I will repeat. There are three steps. Steps number one is actually to draw the flowchart. Step number two is to identify the system boundary plus the DOF, and the step number three is actually to solve the balance. So in this problem, actually, step number one is given, so you don't need to do this one. This is done, and we can go next to step number two. In step number two, it's probably a little bit tough for us to draw it. So let's assign the stream number to it. So let's say this is stream number one, this is stream number two, this is stream number three, this is stream number four, stream number five, stream number six, and this is stream number seven. Next, what we do is that we need to identify the system boundary, uh, all possible system boundary. So we do it from a system boundary involving the least number of unit. Let's say the first system boundary is for unit number one. So for unit number one, so you have here unit number one, you have F1 come in, you have an F2 goes out, and you have F3 goes out. Then you check the degree of freedom for this boundary. DOF equal to unknown. How many unknown? One, two, three. Three unknown. Okay, yeah, three unknown minus how many independent balance? Independent balance is from the number of species, which in this case we have species A and we have species B. So we have two independent balance. And the next one is the physical information. Do we How do we know physical information is to the stream that has incomplete composition? Stream number one, no, because stream number one, no, because all noun A and B. Stream number two, A noun. Stream number three, no, none of them are noun. So basically we can use one physical constraint here, and there is no information, which is minus 0. This one, then DOF equal to 0. So basically unit 1 can be solved immediately. The second possible system boundary is actually unit 2. So you draw the box for unit number 2, and you have F3 come in to unit number 2. You have F4 come in, and you have F5 goes out. You have F5 goes out. So we do the DOF for this stream. DOF. Basically, we count all of unknown. So we have one, we have two, we have three, we have four, we have five, we have six, we have seven unknown. So we have seven unknown. And how many balance? How many balance? First is independent balance. So how many species available? So we have one species A, two species B, and three species C. So we have a total of, here is three independent balance. So it's minus three here. How many physical constraint? We have one, which is F3 here. So, and then we have 2 here, which is F5. We don't know the composition of XA, XB, and XC in stream number 5. So minus number 2. We have no information whatsoever at this unit. So it is no information. So your DOF for this unit equal to 7 minus 3 minus 2 equal to plus 2. Cannot be solved. Next one, you go again to unit number 3, individual unit. Unit number 3. Unit number 3, we have F4 coming in. We have F6 goes out. And we have F7 goes out. We have F7 goes out. I'll use different color. So this is unit number 3. So your degree of freedom for unit number 3, the same thing. So you do the DOF for unit number 3 in this case. You have how many unknown? You have one, we have two, we have three, we have four unknown, we have five, we have six, we have seven, we have eight unknown. So it's an eight unknowns minus how many independence balance? We have how many species? We have A, one, B, two, C. So you have three independent balance minus a physical constraint. We don't know stream number four. So F5, Doria, you have stream number. Can you move a bit over there?
Daddy, I want to open the door.
So you have stream number five, count as physical constraint. We have stream number six, count as physical constraint, but not stream number seven because we know the composition of stream number seven. So you have two physical constraint and we have no whatsoever information. So our DOF for this system boundary is 8 minus 3 minus 2 equal to plus 3. Next one, what is other possible boundary? The other possible boundary is a combination of unit 1 and unit 2. So what does it mean by this one? So it's a combination. I will choose different color. So it's a combination of, let's use green, a combination of unit 1 and 2. So you have another boundary. Okay. This time, this is unit 1 plus unit 2. Okay. What does it mean basically is you have an imaginary box that cover unit 1 plus unit 2 like this one. So in this case, you know that you have F1 that goes in. You have an F1 that goes in. You have a F5 that goes out. You have an F5 that goes out. Sorry, F5. Oh, okay. You have a F5. You have a F5 that goes out. And we have here F4. F4 that come in. And we have F2 that goes out. F2. So next we count for the DOF for this thing. DOF, degree of freedoms. So how many unknown? We don't know M2. So we don't know 1, 2, 3, 4.
Five.
That's all. We don't know 4. We have three species balance, which is A, B, and C. So you have A, B, and C. So you have three species balance. Minus, we have how many physical information? How many physical constraint? We only have one physical constraint, which is stream number 5, because stream number 1 noun, stream number 2 noun, stream number 4 noun, only stream number 5 that is not noun. So this is minus 1, and we have no information. So it's end up with Adoria. It's end up with DOF equal to 4 minus 4 equal to 0. Next, other possible boundary is, I have no space to write this one. Let's do it here. So we have a combination of unit number 2 and unit number 3.
You can do here.
Yeah, we'll do that. To number 3. To number 3, I will change the color to make it simple. Let's try the blue one. Okay, let's try the blue one. So we have this unit 2 and unit 3. Yeah, unit number 2 plus unit number 3. So unit number 2 and unit number 3, again, you have an imaginary box, the blue color here.
The blue color.
Okay, you have inlet here F3. You have inlet of F4, and you have outlet of F6 and F7.
Oh no.
Oh no. Where was it? Where was it?
I don't know.
Okay, we have outlet of F7. Yeah, F7 here. So next to do is, again, you do the DOF. Where are it? DOF equal to uh, let me
Erase it.
get some space here.
What? Kidding me?
So DOF is the same. So how many unknown in the stream? So we have unknown is M1. We have unknown here M1, XA1, X3. We have 4, 5, 6. We have 7 unknown. So we have 7 minus independent balance. We have A, B, and C. So minus 3 minus the physical constraint that we have, which is stream number 6 and stream number 3. So we minus 2 minus no information. So the DOF equal to plus 2. Okay, and last thing is we can have a combination of all. Last thing is combination of all. I'll use different color. What color you like, Adoria? Yellow?
No, I like black. No. How about the light blue?
Light blue. Okay, we'll use light blue for the last box, which is combination of unit 1 plus unit 2 plus unit 3.
Three.
So we make this box. So now actually we have a box like this. We have a box that combine the three of them like that one. And you have input of F1,
What about number
input of
three?
F4, and output of F6, and output of F7. One more is output of F2. Yeah, we have five streams around the units, and we do the degree of freedom analysis for this one. This one
DOF.
equal DOF, yes, equal to, this one is equal to the number of unknown, the same thing. So we don't know, in this case we don't know this. 1, 2, 3, uh,
Four.
4, 5,
Six.
6. Oh no, we know this one. So we don't know 1.
The eraser pen. That's a no mouse pen.
So let me. Hey. So we don't know. Basically, here is this guy. 1, 2, 3, 4. We don't know what else.
Do something new, Daddy.
1, 2, 3. We don't know 4. 4 minus 3 minus 3 independent balance, which is A, B, C, minus 1 physical constraint, which is stream number 6, and this one is minus 0 information. So you get a DOF
D or F?
equal to 4 minus 3 minus 1 equal to 0. So basically, from this multiple unit system of multiple unit, we have 1, 2,
Three.
3,
Four.
we have 4, we have 5, we have 6 overall system boundary. So so now we can move on to the next part, which is the calculation. And now it is very simple. So we start calculating from the system boundary having degree of freedom equal to 0, which is number 1 or number 4 or number 6, that we can start the calculation. Okay. That's all for this problem. Next one, we can move on to the calculation.
Yay. Daddy, I also want to talk. Can I use that for a bit?
Okay. Next one is
You're the orange.
I am. Come on, darling.
I don't want to orange. I'm hungry.
Okay. Next one. Before we do the calculation for this one. Okay. So next one is, let's do the calculation for this problem. So how we do it? We know that unit 1 has degree of freedom equal to 0. So actually we can we can start calculating from unit number one. So you can do many balance in unit number one. So the balance number one is that the total mass that come in 800 then equal to M1 plus 100. Yeah, this is from the total balance. Total balance. So here we will get M1 equal to 700 gram per second. So we can next go to uh, B balance. So next we can go to the B balance. Why we go to the B balance? Because B appears only in two streams, which is a stream number one here and another stream here. So by using a B balance, you will be able to get equation of uh, B 0.8 multiply by 800. Then this one equal to xb1 multiply by m1, which is 700. And by solving this one, we'll get an xb1 equal to let me calculate.
Peel me the orange.
Then
Please peel me the orange. No.
wait a moment, darling. I'm busy. Can you move a little bit?
But I want orange.
8 you multiply by 800 divided by 700 is equal to xb equal to 0. I calculate here 914 0.914. Then you can get an xa 1 then equal to 1 minus xb 1 equal to 0.086. Okay, so the next one is we can start to calculate the next things that has the degree of freedom equal to 0 is actually the overall things. So we do the balance for overall, and you can get actually the total balance, the balance overall boundary. Then here you will get an 800 that come in plus 800 from here. Let me do
800
that.
from here.
Yeah, and then plus the one that come in here plus 200.
You just.
Hey, mm,
Oh, you're gonna look like a last time, Daddy.
wait. Okay, I will repeat. We go to total balance. So you get an 800 that come in, which is this stream, plus 200 from this stream, uh, equal to this total stream out, which is this stream, 100, plus this stream, 475, plus M5, plus M5. So you'll get an M5 equal to
Not orange. Not orange. Not orange.
equal, equal to, wait a moment, darling, 1000 minus 575. This one equal to 425. Okay. What you can do next is you can go to either of the balance. Okay. You can have A balance, B balance, or C balance. So I'm going to C balance because the C, okay, because C actually appears in C only appears here, here and here.
What?
So I can use a C balance.
Why you choose the seatbelt?
Okay, the C balance, then we get 200 that come in multiplied by 1 equal to the one that goes out here, which is 475. You multiply by xc4 plus m5, which we know already, 400. and 75 you multiply by uh, 0.43c. Then by solving this one, you will get an c xc4 equal to, let me calculate. Mm, then it's equal to 200 minus 475 multiplied by 0.43 equal something. Mm, mm, mm.
I want an orange, Daddy. I want an orange pen. Do anything in the pen? Daddy, you have to use a real magic pen. That's a fake magic pen. Pen this.
Oh, I make a mistake here. So stream number 5 is 425. 425. So let me do, it's 200 minus 425 multiplied by 0.43. Okay, divided by Doria 475. No, 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 no. Equal to something. You divide it with 475. Then this one equal to 0.036. Then you can do balance for then you can go next to the B balance. Then you can go to the C balance. Then you can go to the next, and so on and so on. Okay. I'm sorry that this is the first trial. I think we can do it well. So I will end up the lecture up to this point because my daughter is morning all day. Next time I will have a better arrangement so that when we can do it better. Okay. So that's all for tonight's lecture. Thank you very much, and that's all. Bye bye.